So the topic I'm going to talk to, see if I get this all working, is about vendor evaluation. So we have heard a lot of presentations of how to go about it, how to do trials, other presentations of the different steps that are needed if you do an IPv6 integration. So that part that I am going to cover is that at some point you have to find out who your vendors are going to be for your future IPv6 network. So the topics are where to start, what are the basic requirements that your future network devices of any type should be covering. Then we look at requirements that you have for specific devices. So there are some basic requirements that every device needs to be able to do, and then there are, depending on the type of device, there are specific requirements that you want to look for. And then we look at testing and labs, and we've already had some presentations on labs, so there is some overlap here, which is good. And at the end, I'll show you some references. So, full IPv6 support, we've heard that before, right? When you purchase anything IT-related, make sure it fully supports IPv6. You saw that on a previous slide today, and you've heard it many times in other presentations. And you see this dollar roll here. That's because if you look at this, if you take care of this, this is where you can save a lot of money. So with all, even if you don't have a real detailed plan or you don't need to do IPv6 today and tomorrow, if in all your purchasing you take care of how you need IPv6 support, you can save a lot of money, because whatever device you buy that has a longer lifetime than a year, it will most probably be needed in your IPv6 network, so it should be supporting IPv6. Now, the problem is that in many cases on vendor brochures, you will see this little checkbox that says we support IPv6, but that may not be sufficient for what you need. In many cases, I've seen the vendors say to me, well, yes, sure, we support IPv6, and maybe it was a security device. And then I said, well, please show me what you can do. And so all you could do was to assign an IPv6 address to the interface of the box. Well, that's not really what you need from a security device, right? It's a good starting point, but maybe not all you need. So this is why you have to become specific about your requirements. So where do you start? Well, usually before you get to this step, you have completed some other steps of your IPv6 planning. You hopefully have a high-level integration plan. And in this plan, you have defined your goal of where you want to go. You have also looked at milestones and of the individual steps needed to get where you want to go. So for a larger enterprise network, the whole process of getting where you want to go will be maybe 3 to 5 year process if you want to do this in a digestible way. And that's why you should be starting today, so that you have the time for these steps and that you can do careful planning. So you may already also have done your assessment, and I think we have someone speaking on assessments tomorrow. An assessment means you have looked at your current equipment and you have tested it for how does it support IPv6. So you will have equipment or applications in your network that supports IPv6 to your requirements. You will have other equipment that needs upgrades, that can be hardware upgrades or software upgrades or maybe both. And then you may have devices or applications that you will never be able to use in an IPv6 network. So you will have to find specific solution for those or find a replacement for them. So that's probably the steps you've already gone through. And now, the moment you have a high-level plan and you know where you want to go and what the steps are to get there, only when you have this picture you can create a list of IPv6 requirements. Only if you know where you want to go can you define what you need to get there, right? Sounds like a very good general recommendation, not just IPv6 related. So there are some rules when you go about this. So you have to define your requirements carefully, and you have to align them with your plan of where you want to go. Now, there is one thing that you should not do. You should not trust your vendor to know what you need. right? IPv6 is an early world, and we're all in the same boat. And like Chip said, there is not very much operational experience out there. We're all starting to get familiar with this, and that's true for customers, that's true for ISPs, and that's true for vendors. So we need to work together. So you cannot assume that your vendor, no matter who it is, knows everything and knows exactly what you want. So you have to do your own job, you have to do your training, you have to understand what IPv6 is, you have to create your high-level plan, you have to define your requirements, and then you can start talking to your vendor. And maybe you have a vendor that can help you with this because he's done a lot of work, but maybe you just need to tell him exactly what you want. And then he may be listening and working on it, or you may suddenly figure out that he may not just be the right vendor for your future network, right? So, but you got to talk to him, and you can only talk to him if you're informed, and if you can clearly say what you need. So, and then one last point just on the summary slide is what I've seen very often is that people base their designs on bugs. And I wouldn't do that. If you create a design for your future IPv6 network, the best thing you can do is try to understand what's new about the architecture of IPv6 and how you can make best use of this in your network. So you want to use the advanced features of IPv6, right? That's part of your high-level plan. You're not going to try to copy what you did in IPv4 to IPv6, because that would be like a straitjacket. You wouldn't use the advanced capabilities of IPv6. So you really got to understand what IPv6 can do and then design for your next generation, for your future network. And so what I often see is people say, oh, we don't want to do this, or we don't want to use that feature because it doesn't work. I said, well, you're not going to base your design on something that currently doesn't work because there's a bug in the code, right? You expect bugs to be fixed. And you still try to plan for a nice network, right? Not a network that is based on workarounds about current bugs, because bugs are usually temporary appearance. So, important rule. Oh, it works. So, let's start out of how do you evaluate what you need for your different devices. So there is an RFC about node requirements. It's RFC 4294, which defines the minimum requirements for nodes. And how do they define nodes? The definition in the RFC is a node is a device that implements IPv6, very general. That's good. It can be anything, right? As soon as it talks IPv6. And then a node that forwards IPv6 packets that are not explicitly addressed to itself is a router. He's still a node, but he's also a router. And a node that is not a router is a host. So that's very clear RFC type definition of what we're talking about. Now, if you look at this RFC, you find a list of requirements. And just to give you a general, I'm not going to read the RFC to you, I'm not going to read that list to you. What I want to show is what type of information you find in there. Because that's how you have to approach and classifying what you have and what you need. So when you have your design, you will have some basic requirements that every device in your network must meet. And these basic devices, you will have two categories. You will have options that must be supported, and you will have options that should be supported. So you're starting to build your list for your equipment of these must options that you want to have, like, oh, this is the pointer of, obviously, IPv6 basic RFC 2460 support, right? You want to have ICMP v6. You want the IPv6 addressing RFC being covered fully. You want to be able to do stateless address auto configuration. You probably need a DHCP v6 client, etc. So you make this list for your devices of what you want to have, definitely what you must have, and then other things that you should have in your devices. I'm struggling with this, So now you have to become more specific, because every device must cover some basic IPv6 requirements, but specific devices need to be able to cover specific features depending on what their function is that they have in the network, such as layer 2 devices Hosts, clients and servers need specific requirements, have specific requirements, routers and layer 3 switches, and then finally security devices. So there you have to become really specific. So for each type of device, you will have a list of basic requirements, a list of specific requirements, and you divide that list in mandatory features and optional features. And the features that you need for the specific different types of devices depend on the design that you have, right? So you may not, if you have a firewall or a DHCP server, you don't say to the vendor, well, I want you to support everything. You have to look at what you need actually in your network to go from where you are today to where you want to be in the future. And you will probably not only want that type of support, but you will also look at things that you may not need immediately, but that you want to have on a roadmap, right? So you got to talk to your vendor, and you have also to check the roadmap of the vendor. So features you need depend on your designs and your integration plan. So the integration plan will also tell you about what transition mechanisms you need supported at what time in your network. So these are all things to check with your vendor. So the first thing is to require. So you got to find vendors that say, well, yes, we can support what you need, what you provided us in your list. But then never believe a brochure or a checkbox. Once you have equipment from a vendor that you think this will do a good job in your network, well, you had a nice presentation this afternoon about the lab and how you should be working in your lab. You take it there and you see if it works, you know. And also, and I think that's been pointed out in this discussion, I mean, some things may work, but only under specific conditions or in specific combinations, so you have to check all the interoperability issues. And so the closer you can match your lab to your production environment, the better, right? You have to test these different types of equipment in a scenario that resembles as closely as possible your real-world network, because only then it really tells you something. And you have to expect bugs and incompatibility issues, because most IPv6 stacks, they are young stacks. They cannot be mature. They cannot be as mature as an IPv4 stack. And I mean, even today, I mean, more than 40 years after the invention of IPv4, we still find bugs, problems, and security holes in IPv4. So how should it be possible that our IPv6 stacks are perfect? And because they're so young, they will probably have rather more issues than less issues than an IPv4 stack. So you have to prepare for that. And in order to be able to detect bugs, you must really understand the protocol, right? If something doesn't work in your network, well, maybe it's a bug, but maybe you've just misconfigured something. So you need to have a good general understanding of how IPv6 is supposed to work in order to be able to determine whether you just happen to have a configuration issue or a bug. And then if you have a bug, it will take some time, because now you have to go to your vendor and you have to work with him, and you have to probably go through the incident process, and you have to give your vendor some time to fix the bug. So the introduction of IPv6 may be an opportunity to reassess your vendor portfolio. Well, maybe you're completely happy with your vendors, then everything is fine. And I had customers where we were really careful about some recommendations, well, our thoughts that we had about the vendor choices in that network. So we tried to sort of remain neutral and just point out what was important, because we thought they didn't want to change vendor for a specific product. And then finally, we were really careful in our report and in our discussions, and finally we found out that the customer said, well, we're really happy to switch that vendor, and IPv6 will be a good reason to do that. So you never know how it's coming out. What you have to be aware of is that if somebody has been a great vendor, or if something has been a great product in IPv4 with best performance and best functionality, or somebody has been your best provider for IPv4 with great performance, it doesn't include that it's the same for IPv6. Specifically, probably if it comes to like machines that have heavy load, like high High-end routers, if they have a great IPv4 performance, it doesn't mean they have a great IPv6 performance, even if they support it in the checkbox. So if you evaluate for IPv6, you have to specifically look at how does this type of device or this application or whatever it is support IPv6. And you want to see performance reports, and you want to test them. And you want to test them in combination. So if you plan for a dual stack network, right, you need to be testing those devices. How do they perform on the load for both protocols, if that's how you want to run them in your environment? I mean, very good IPv6 performance in itself is not a good thing if the box needs to handle both IPv4 and IPv6. So you have to find out how far can you go and how much does it take. So verify and test the features and the functionality that you require as number one. But not only that, you also test performance and load behavior. So for instance, some box may be very good and performant in IPv4 because it does it in hardware, but it only supports IPv6 in software, so that would probably not be the best type of equipment in the long term for a high-performing IPv6 network. So you have to be really specific in what you're looking at. So, and then also, as we heard in other presentations, test your different mechanisms that you plan to integrate. So you have this design plan of how you want to go, where you want to be in a couple of years. And so you're probably going to make use of different transition mechanisms during that time, maybe different in different periods of that transition. And so you have to test those in the combination that you plan to use them. So what are the criteria for choosing a new vendor? Well, just the fact that he has a piece of equipment that currently supports what you need to do may probably not be good enough. And I mean, I'm talking about vendors that from them you buy applications that are important to your business and that you want to use on the long term. So you gotta, I would want to work with vendors where I can see that there can be a good partner on the long term. So I would look at the whole product line. Even, I mean, what other products do they have that I may not want to use today, but may need to use in the future? I will assess the functionality of the products that they offer and also the performance of the products that they offer. And then I will also assess what is the vendor's testing and Q&A procedures that they have. So that, because that gives me a certain guarantee, you know, of that what's coming out of this vendor has been tested and I'm not his first and best test market. And I will also assess his support. I mean, if I buy hardware or software that I heavily, my business, my network really depends on, I want to be sure that I have the same level of good 24/7 support that I have for IPv4 and that he has a crew of people that can support the device or the application in a professional manner. And I will also assess his roadmap. I don't want a vendor that is just up to date today, but then will not invest anything for the next couple of years because that's how he can optimize his profit. I want a vendor where I can see that he is in a continuing process of updating his equipment, of optimizing his equipment, of developing new solutions and products. So that would be like a good list of criteria that you can use to assess your new vendors or get confirmation that your current vendor is the best that you can have. So the importance of labs. The lab offers many opportunities for things that are very important if you want to integrate IPv6. One of the first things is you just create a lab because you need to get playing. It's like you played yesterday in the lab back there. You need to get your hands on the stuff, even before you do final designs. You cannot do a design that will work in a real-world deployment if you've never touched IPv6. That doesn't work. So you use it for education in the first part, to gather experience. You play with different scenarios. Then you start to test for performance, features, and functionality of products. So while you're assessing your network and while you're assessing new vendors, you can use the lab to run performance tests and load tests. You will find the bugs in the lab, hopefully. And you will also test the bug fixes that you get in your lab. Then you can test all the compatibility and interoperability issues that may come up in using different vendor products. You can also test the deployment scenarios according to your integration plan. So you have a plan of how you want to do the next step and how the process will look like. So you will test these steps as closely as you can in your lab before you do it in your production network. You can work on and test how you manage your future infrastructure. So you cannot just introduce an IPv6 network and not know how you're going to manage it, right? So you have to have the management tools in place that you need. You need to have your support organization in place that can manage that network. You can test your deployment steps, and it's also the best place for your support people to get trained before you have live data on your network. So the outcome of the testing is it provides experience. It can show you hidden features that you weren't aware of. It's an opportunity because based on the experience you do in the lab, you can refine your design or your implementation plan. It reveals bugs, and by doing all of this, it minimizes the risk for your IPv6 deployment. So an important note again, plan for enough time for bug fixing, because there will be bugs. Traffic flows. Here's a nice traffic map. You will also have to look at your network and understand, according to your design plan and implementation plan, of how that will change traffic patterns in your network, and if your network can do it. Some people think that running a dual stack network means you're going to double your traffic, but that's in most cases probably not true. If you have the nice situation that you can build a dual stack backbone first and then gradually start to migrate applications from v4 to v6, you will simply have a gradual shift from traffic going over IPv4 to going over IPv6. Because if you have a dual stacked backbone and you have dual stacked clients, they will use IPv6 to access applications as soon as they are available over IPv6. So that's how it will just naturally happen step by step. So it will not just double, it will shift from IPv4 to IPv6. So, and this traffic map is Paris. So here's some links to further information. There is the USGV6. We have seen that today. You have seen the other link. So that's a very good link here, where you will find plenty of information on anything you want. They also have a list of labs that test. They have lab guides and checklists that you can use. Tested product lists, buyer's guides. So this is a really good resource to go and find more information. And then there is a similar document that was created in the RIPE region, in the European region. Here's the link where you find it. It has best common practice template that you can use if you want to do tenders. It also comes from the government space. And then last but not least, you have the International IPv6 Forum that created all these certifications, the IPv6 Ready logo program. And there you can also go to the IPv6 Ready logo site. You will find links on the IPv6 forum page. And when you go to the IPv6 Ready logo page, you will find a list of vendors and products that have certified to get the IPv6 Ready logo. So that was my presentation on vendor evaluation. And Ed mentioned my book, IPv6 Essentials, which is a technical description, like a summary of the RFCs, of the specifications of how IPv6 is supposed to work. And my later book, which was just released in September, is on planning. So that's not a technical book, that's more on how do I go about the planning process if I have to integrate IPv6 in an enterprise. So you made it through your last presentation, and we hope that the drinks are back there, right? So I'll see you for a drink, okay? Thank you very much.